Well, hello. I've recently added history matching to my water flood simulation. So what I'll be doing in this video is going through two examples from this textbook here, Enhanced Oil Recovery. The first example I'll be doing is example 3.1. This is what the output of that example looks like. Here is recovery factor, and here is dimensionless time. So I'm going to take dimensionless time, or pore volumes injected, and recovery factor, and put that into the Excel spreadsheet, which I've already prepared. So that just looks like this: pore volumes injected, recovery factor, and then I've also plotted the two here. So in order to put that data into my program, I have to, that's old data, I'll just delete that. It has to be called data, and it has to be put into the main folder here, so that when I open my program, it will be loaded into it. Alright, so when I open this, what you'll immediately notice is all the default values that are automatically populated into the program. Those are the same every time. I just have them as placeholders. Here's your fractional flow curve, and here's your relative permeability curves. Of course, this is still, I believe, version 0.715, so eventually I'll add like titles to these and everything like that, so it's easier to understand, but that's the easy part. The hard part is to get the simulation to work, which is what I've finally done. Anyways, so if I update this, you'll see that you get your SW and your FW values here, and if I run it, you'll see that you also get your slope value. Here's the history matching simulation. This is recovery factor versus dimensionless time or pore volumes injected. I'll run that one more time. As you see, this is the flood front here. As soon as that passes, it's going to cause this recovery factor to go in a different direction, because now you have water in your output stream in your producing well. So anyways, you can obviously tell these dots here are the actual history data. So those are what I'm trying to match, and the red line is the simulation. So if I've got a good match, the red line and the dots should match. But right now, it's not a very good match because they're not on top of each other. But if I switch, I already know what the answer to this is, of course. So if I switch this down to the water viscosity back down to 1, update my curves and my permeability, hit run, you'll see this is the solution. So the red line will change direction at the appropriate point, and the simulation will match the data. This means there's a good fit, and that history matching for this sample set is done. Now I also added another example. I believe that example is a surfactant example, but I'll have to double check just to make sure. So I'll open that now. I'll close this down. Okay, I'll remove my data from example 3.1. Go into the second example, which is example 3.5. Here's the output data. So this is actually right here is recovery factor, right? Because it's just SW minus SIW divided by BO, but we assume BO is 1. So this is recovery factor. This is your dimensionless time or pore volumes injected. So I'm going to just take those values and put into a spreadsheet, which I've already done, which is here. So these are the same points as before, and here they are just on a graph, so you can see them. So again, you should see something like this when I load the data into the program for history matching purposes. So I will put the data, actually I'll copy it and paste it in there. So I'll open it again. And now if we run the exact same values as last time, you'll notice that we won't match, not even close. So there's no way that this line will get here, and I guess you could wait to see. But anyways, so I'm going to click the, because I already know what this is. I know that there's a surfactant in here. Or actually, I think this one is just, no, yeah, this is the surfactant now that I remember. So the viscosity of the surfactant is 4, and it has an adsorption of 0.8 and SOR after chemical flooding of 0.1, which is different than the regular SOR, which was 0.3. So anyways, I'll update my fractional flow curves, which now you see 2 curves. They're split at the top because they have different SORs, right? Residual oil saturations. And here you can see both of the fractional flow curves the relative permeability curves. So the blue relative permeability curve is for this fractional flow curve, and the black one is for the black fractional flow curve, right? So anyways, I'll run this simulation again. And this is the correct solution. So what you should see is that the red line will go through the center of all of the circles. And again, the circles are the actual production data. And the red line is the simulation. So yeah, I'll let that finish running just for the sake of it, but that's pretty much it. Thanks for watching my video. Okay, bye.